All right, people, back again. Seems to be some issues and conflict and controversy out in the wonderful world of climate change. I don't know, I probably watched close to 100 hours of climate change videos on YouTube. Got hundreds of hours of reading reports and documents and God, you name it, everything under the sun. So a lot of people going in the right direction. I think Milankovitch, he's like the leading theorist, theory that a lot of your scientists use when they're confronted with what causes the ice age to happen. It's hysterical though when you have these brilliant scientists, they get cornered on this one particular question, and they all have the they're talking high, they're all proud, spitting out all these all this information, data and numbers and equations and theories and dates and times and graphs and everything. When you hit them with what changes, what actually tips us into an ice age, what precipitates the ice age, what causes the ice age, they all drop down to this monotone type of, well, is that the obliquity of the earth goes around the sun, it goes circular then, and they can't wait to skip off to the next topic. They're just buzzing right through to the next topic. Let's get the hell out of here, because the bottom line is it's a theory with no mechanics. And then some of them go out, well, Jupiter and Saturn and the bigger planets in the solar system caused the Earth to go into a more circular orbit. I'm like, yeah, it's just absolute nonsense. I mean, most of the planets do a complete revolution around the sun in like a couple hundred or 300 years. So, I mean, we're talking about a massive amount of time in an interglacial period, never mind a massive amount of time in an ice age. So I'm here to shed a little light on what it is that drives the ice ages and the interglacial periods here on Earth. I know a lot of you people know me. I'm a big moon guy. I got a couple of books out. Both of them have a picture of the moon on it. We'll get into my books later. I'll spare you the sales pitch and give you this. I mean, this is very important to me. This is close to my heart, and it's people need to know exactly what it is that causes these things, so they can stay on top of it, get the warnings. And right beside me right here, the moon. The moon is the biggest driver of these cycles, these huge cycles. So we'll get into why. We'll get into the leading theorists. We got a couple of great guys coming up here in some slides. We got Milankovitch and Al Gore and a few other theories, but for the most part, those are the two big names out there now. You get the IPCC. I sent them a letter notifying them of this theory I have on the moon driving the interglacial and a few other cycles here, the ice ages and the other cycles on Earth, but they haven't got back to me yet. So I'm just putting this stuff out. It's like I think you guys might want to keep an eye on these things. Now I don't want to undermine the clean energy and the lowering the CO and the greenhouse gas and the methane and everything else, but you still need to know the truth of what it is that causes these ice ages. So you're better off, so I don't want to say, okay, we just go off, blow off and burn coal because it doesn't matter. That's not the case, because I do believe that in all the statistics out there that there is some kind of an effect with human activity that's driving the us into an ice age a lot faster. So here we go. Here's my main man, Milankovitch. At his time, born in Serbia, same place Tesla was. Great theories, great mind. Again, he did the best he could with what he had at the time, and he's got it was right on the money. Precession, tilt, obliquity, and the eccentricity of the orbit around the sun. I mean, these are all big moves, big plays, but mind you, there's no evidence. There's for the eccentricity changing around the sun, the Earth's orbit, there's just no evidence whatsoever. and a lot of scientists come to agree that they're in the same mindset, that you're still taking in the same amount of BTUs. Basically, if you were a circular orbit or an elliptic orbit, it might even be warmer, I think, in a circular orbit. So, with that in mind, you have precession. Now, there's 26,000 year precession, 12 zodiacs in that precessional cycle. We're in it goes backwards. So we're in March right now, and we're in Pisces, and we're going into what's that one? Aquarius, and that's like February into January. So we are in the winter season, because there is a season with precession. It's not the driver of the ice age. This is a 26,000 year cycle, and there are seasons in precession that actually you can trace from the ice samples and see how the ice samples go down and come back up, as far as temperatures on Earth. But it's not the big plunge. The big plunge is the tilt. So Milutin did say that tilt could cause it, but again, no mechanics behind what causes a tilt change. There again, John Shaughnessy shows up, and it's the moon. There's another picture of the Milankovitch cycle, the eccentricity, the elliptic, the precession of the Earth. Right here is the, I'm just going to blank out a little bit with these bright pictures. Not that you need to see me anyways, I'm just a talking head. So we have precession in red, obliquity, eccentricity, solar force, and the hot and cold stages of glaciation. So, I mean, these guys are brilliant. They can squish their graphs together. They can, change the timelines. They can, the temperatures, the data. They can make these things look like they actually have some kind of a correlation between each other, but they really don't. There is, the only thing that's got a correlation is the Earth's tilt. And a lot of these things, I mean, these things are going back 1,000 years. I mean, we got some data. We can play around with the data for 1,000 years, but it's not really that good. Here's my man, Al. I support Al, We love Al. Al for president, Kind of a world would have been. We still have, I'm not going to get into the politics. But anyways, Big Al here with his chart. He's got his chart here showing that the CO2 limits are, we're at 400 now. First time we've been at 400 ever. CO2 is usually, as far as the ice core samples, are about 250, 260, whatever. I think we just hit 395 parts per million. And then he's showing a graph with this. He's actually, I don't know if you can see it, but he's actually on a man lift that goes up to like 700 or 800 or something like that on his chart. But mind you, what Al knows, I mean, he's jumped on the wagon with the ocean conveyor crowd, the melting salinity, not the melting salinity, the melting ice dilutes the salinity levels, and then you have an interruption in the conveyor. Again, I forget this guy's name, the scientist. Was he from Penn State or someplace like that? He was the one that formulated a theory. It got published and everybody jumped on it. It was in the 60s or the 70s. They said that the melting ice diluted the salinity, the dense salinity levels, and interrupted the conveyor, ocean conveyor. My theory is water's melting at the water's melting. Ice is melting. I don't have my teleprompter, I never do, so I don't have anything written down, so you're just hearing my mind, and that's it. So hang in there, people. I'm going to make a point at the end of this. So you have, your ice melting, and it's dribbling into the ocean, but it's not like, it's not smart ice. It's not going directly to the dense salinity levels. It's going into an ocean, right? I mean, so it's currents, and it's not targeting the dense salinity levels. It's basically going in and being absorbed by the whole ocean. So the percentage ratios are staying the same as far as dense salinity and the low dense salinity that makes up the outside the conveyors. Just a theory. Yeah, it's just that's I'm not saying it's not true, but I just don't believe that this is going to collapse the ocean conveyor. That being said, if you have a large, massive dump, like say, the Hudson Bay area, somebody theorized that there was like 1 trillion gallons that got locked into you know, a big pond or a big lake up there, or a massive inland freshwater sea, and then it finally made its way to the ocean and just overnight dumped 1 trillion gallons of fresh water. Yes, I believe that would affect the ocean conveyors. Yes, I do see that disrupting it, but it is not the driver of the ice age. It is not the driver of the interglacial periods. It does not drive it. There's some global warming energy flows from reflectivity and solar radiation, atmospheric windows. Yeah, there's some logic in there. There's, you know, for every chart out there, there's another group of people, you know, disproving the chart, saying, you know, one group of scientists saying as CO levels go up, temperatures go up, and then other scientists are saying the exact same opposite. I'm like, how can we be so far an extreme on this simple, you know, reading of the ice core samples? So I don't know. I don't know why we're off the beam on this. Well, you know, there's money, there's buku bucks. I didn't realize how much money was involved in this climate change, global warming, you know, thing. But it has turned into a, you know, $100 billion a year enterprise. But like I said, the spin-offs are great. Clean technology, much more efficient, fuel efficient cars, heating systems, what have you. So it's a lot more conscientious of the way we live, which is always a good thing. Here's a quick simulation of global temperature change from 1850 to 2100. You can see it's walking its way out. We can just wait until it plays out. It's a neat little GIF. So there is changes going on. People, they are seeing some changes, and it's like a giant spider web to me now. But anyways, it's getting up there. It's about a 5 degrees Celsius change from over a mean global temperature from 1850 to 2100, just 5 degrees. Here's your great ocean conveyor belt. The big one that's of particular concern is the North Atlantic, because you know, it's like if it collapses, you know, Britain's on the same latitude as Alaska, so that doesn't, you know, obviously you can see there'd be some stark cooling going on in Northern Europe. Again, this is not going to drive any ice ages. It's not going to drive any ice age unless you have a massive, you know, 1 trillion gallons that just dumps into the North Atlantic, which I don't see it happening from the Greenland ice sheet. That's kind of just melting off, and even if the whole ice sheet just slid into the ocean, it still wouldn't dilute it. You got the Iron and Bronze Age. This interglacial period basically started about 13,500 years ago. And then we have the Younger Dryas period that, you know, there's a lot of theories on the Younger Dryas period, like, because all of a sudden everybody, you know, the animals were migrating north in Europe, a lot of mammoths, and, you know, the animals were eating the grass and vegetation, and then all of a sudden overnight they were just flash frozen, just flash freeze, and just froze to death in the tundra. And they're actually exhuming these bodies as we speak, and you know, the vegetation was still in good shape. You know, it's still somewhat holding you know, minerals and proteins and things. So what happened? What happened? Well, we talk about that massive water reservoir up in the Hudson Bay. I forget. I wish I did a little bit more research on these people to come up with these beautiful theories, but I mean, you have a massive, you know, increase in water flowing into the ocean. It changes the drag of the moon's drag on the ocean. So, in a nutshell, I'm throwing out that the Younger Dryas period, that we had a huge drop in temperature that caused northern Europe about 10, 11,000 years ago, just to go back into like a mini, you know, an ice age, really, for 1,000 years almost. And I'm saying that the tilt actually went back to an ice age degree tilt. So there you go. The bottom line is, when you have a massive increase of water into the ocean, it tipped it back to the ice age tilt, and then and then as it settled back out, the ocean settled down, and it went back to the present 23.5 degrees interglacial period tilt. So it probably went down to could have went down to 20 or 11 during that period. Central Greenland climate, abrupt change. That's the Younger Dryas period again. Just they get some great evidence of that drop in temperature. Again, it's all about the tilt. It's all about the tilt, people. The moon is the driver of the interglacial and the ice ages. This is a nice, just a snapshot. An ice age Earth on your left, and the interglacial period that we're in right now on the right. It basically shows everything. And interglacial period, this is going back 1 million years, and you can see, let's see if I get my laser beam up and running here. You can see the peaks here. We're at right now. We're just over here on the left-hand side. We're just creeping up. We haven't even got to the hottest yet, as far as temperatures in this interglacial period. So it's like don't get rid of the bathing suit. Yeah, we still have a little ways to go. So as you can see, there's somewhat of an even interglacial period. But what I wanted to show you is these little steps in between the interglacial periods, the red peaks. That is precession. That is the seasons of precession going on with changing the actual temperatures. So what's frightening is we are in the winter time of the precession right now. We're going into February, and then we're going into January, and so we're in the winter cycle of the wobble of precession. I don't know if you know what precession is. You know what I'm talking about. So we are in the winter season. So if in fact we do get into a tilt, and we do have a tilt. The tilt is changing as we speak. People are marking the changes in Mexico the last 10 years, and it's marching 100 feet, every year or so towards the equator. So there is a change in the Earth's tilt. Here's the origin of tide. The gravitational effect of the moon creates a tidal bulge, right? This is drag. This thing's just like your hand grabbing a globe or a ball that's spinning, and you're putting your hand on it to slow it down, or your tire on a bicycle. You put your hand on it. It's friction. So basically, I don't know. I hope that GIF works. Is that GIF going to work? Can you see it? Let's see if I can't get this GIF in here. I'll try to get this GIF a little bit better. This is actually a great rendition. One of them renditions of. Try to get that so it comes down. It's a very bright GIF. But I mean, here's the. Basically, in a nutshell, this is the, I want to get rid of this. Come on, don't fail me now. Where's menu? Exit menu, see you later. Right here you'll see the tidal bulge. This is the moon. This is like, a serious energy force that has been overlooking, because the moon has been put on the pay no never mind list as far as having any function at all on the planet. So it is the actual driver of the tides and the seasons, and it flexes every tectonic plate on the planet twice a day, whether you like it or not. This thing is a beast, and it's the only reason we have any kind of a high level of complex life on the planet. I'm not saying the humans are, but anyways. High tide, you flex the Barry center and you lower the gravitational field on the other side. That's Shaughnessy's law of gravity 5 or 6, I think. But anyways, you lower the gravitational field on the other side, and then you have a bulge, because the gravitational field's lower on that side of the planet. Anyways, it gives you a good idea. There's the planet spinning roundy, and the moon is, holding the bulge, basically. It's just holding the bulge as it goes across. Here's another beautiful picture. Here's the Earth moon. This little moon thing right over here. Right here. She's the workhorse behind this beautiful environment that we take for granted. Well, some people do, not all of us. NASA, another four-letter word. According to NASA, Earth is actually an oblate, pear-shaped spheroid.